Hello everyone. Today we're going to explore one of the most important foundations of natural language processing: how machines understand and represent text. Let's get started with an example. Suppose we have this string. For us, it is easy to see where the words are, but for a computer, it is not that simple. Tokenization is the process that helps the machine break a string into individual words so it can understand the text. Here, our string enters the machine and gets split into individual pieces. So what comes out of the machine are the tokens. Tokenization is the first step in natural language processing that turns text into smaller units. But as you are noticing, the tokens are now free of punctuations, and even they are lowercase. This is so-called normalization. It makes everything simpler, cleaner, and easier for the computer to understand. We should note that computers don't understand language the way we do. For example, to us, lovely with and without an exclamation mark mean the same, but the machine sees them as two completely different strings. Similarly, we might have a dot right after a word like cute, or we might have a capitalized word. Normalization isn't as simple as it sounds. It really depends on your goals. For instance, lowercasing everything or removing exclamation marks might not work well in sentiment analysis because they can carry emotional cues. So, normalization isn't one size fits all. It should always align with your specific task and objectives. Now that we have understood how the machine splits our sentence, let's look at how we can do the same thing in Python. Let's jump into the code. As you can see, it's actually very simple. In the first line, we initialize a text. This is the string we want to process. Next, we normalize and clean the text by removing punctuations and converting everything to lowercase. Finally, we split the text into different tokens. This is done using the split function, which automatically separates the words by spaces. Very straightforward. In just a few lines, we turn raw text into a list of tokens. Later on in this video, you will understand how a library such as spaCy can do these kind of things automatically. Once we have our tokens, we can represent the whole string as a bag of words. This simply means we count how many times each word appears without worrying about word order. In our example, the words this and is appear twice and the rest appears once. Bag of words gives us a simple numerical representation of the text, a vector of word frequencies, which a machine can understand and work with. For example, if the word this appears twice, its box will contain a count of 2. This gives us a simple numeric representation of the text, how many times each word occurs without worrying about order or grammar. Now, let's jump into the code for bag of words. We have already covered tokenization, so we will skip this part of the code as we have already explained how tokenization works in Python. Now let's focus on what's new, the bag of words section. We start by creating an empty dictionary called BOW. This will hold each unique token as a key and its frequency as a value. Then inside the for loop, we go through each token one by one. If a token already exists in the dictionary, we increase its count. If not, we add it with a count of 1. By the end of the loop, we have a clean frequency map of the entire text, our bag of words. And this is the same idea we can use for things like spam detection by checking which words appear and how often. Imagine this is an email. It contains words like free, prize, and award. In many spam emails, these kinds of words appear very often. With bag of words, we can easily detect patterns like this. If these tokens appear frequently, it can be a strong signal that the email might be spam. Of course, real spam filters are more advanced, but at their core, they often start with word frequency analysis, exactly what bag of words gives us. Now, let's move beyond simple counting. Unlike bag of words, word embeddings can capture what the word means and how it relates to other words. Each of these boxes that held word frequencies will now turn into small circles representing individual words. But instead of just a count, each word now carries something much richer, a vector of numbers that describes its characteristics. Let's highlight the word lovely as an example. In word embeddings, each word is described by many features. Each of these features can be represented by a number, and together they form a vector. In real NLP models, this vector doesn't just have a few numbers. It often has around 300 dimensions, each capturing a subtle aspect of meaning. But here, just to give you a deeper understanding, we have reduced them to 6 features. Imagine each number is associated with features such as emotion, sentiment, intensity, value, domain, polarity, and more, which is a simplified representation to better understand the intuition behind embeddings. Now let's look at a chart that represents each word's embedding. On this chart, you can see each word represented as a point in space. Some common words like this and is are missing. That's because they are stop words, words we usually remove since they don't carry meaningful information for analysis. What remains are the important words: cat, dog, lovely, and cute. And notice how they are placed on the chart. Words that are similar in meaning appear close to each other. Here, lovely and cute sit side by side because they share similar emotional tones, while cat and dog form another nearby cluster. This is the real power of word embeddings. They don't just tell us which words exist, they reveal how words relate and connect in meaning. Now let's step into the code. On the first line here, we import spaCy to use its NLP tools. spaCy is a powerful and fast NLP library in Python. It can understand, process, and analyze text. spaCy is smart by using machine learning and pre-trained models to understand language contextually, not just by simple rules. In the next line, we load a pre-trained model from spaCy. Encore Web MD is an English medium-sized model that already understands grammar, word meanings, and relationships between words. This model has learned from millions of text examples, so it knows how words relate to each other. Previously, we lowercase text and remove punctuation and stop words, but now let's keep them. spaCy is smart and can understand different forms of text while keeping the original text intact. It preserves capitalization, punctuation, and stop words. Next, we assign a text to a variable. In the next line, we pass the string to the spaCy model. The model processes the text through its pipeline. Each token becomes an object containing linguistic features. In fact, spaCy tokenizes, tags parts of speech, identifies named entities, and creates word embeddings. And finally, we iterate over each token in the doc object. Inside the loop, token.text gives the word itself, and token.vector gives the word's embedding. Now, let's test whether spaCy is smart enough to differentiate between two identical words with different punctuation. We will replace lovely with cute, followed by an exclamation mark. This gives us one instance of cute with a period and another instance of cute with an exclamation mark. Next, we rerun the code to observe how spaCy handles these variations. As you can see, the numerical representations of the two words are the same, even though their punctuation differs. Thank you very much. Feel free to share your thoughts, and if you found this helpful, please support the channel by liking, subscribing, or sharing.